Okay, so let us see the next question in a binary search tree playlist. That is the Ceil in the BST. Okay, so we know what's the unique property of the BST कि हमारे पास जो root node होता है, let's say A, B and C, right? So yes की जो right child होती है वो greater than root node होती है, right? And the left child is lesser than the root node. ठीक है, so this is the unique property of our BST. So let's say we have this given this BST and we need to find the Ceil in the BST. So Ceil is nothing but you need to find the nearest value greater than or equal to x, right? तो हमारे पास x की वैल्यू क्या रखी है 25. सो नीड टू फाइंड द ग्रेटर देन इक्वल्स टू x एंड इट शुड बी नियरेस्ट टू x, राइट? 25 से बड़ा इस BST में कौन कौन सी वैल्यू है 30 एंड 27, राइट? बट नियरेस्ट टू x अमंग 30 एंड 27 इज 27, राइट? सो आंसर हियर वुड बी 27. अगर x इक्वल्स टू लेट्स से 30 होता तो हमारा आउटपुट हो जाता 30 because 30 itself was present and we need to find greater or equals to x, right? So let us see हम इस particular unique property का कैसे use कर सकते हैं. Please pause this video and think for some time and then resume it again. So okay, so we have this particular key 25, right? And we have this node, root node at the first level as 10. So let me use a different color. So now the x is greater than the existing root node, right? So that means we need to make a move. We need to make a move, either move in the left or right. Where, how to decide it? My current value is 10 and I need to make it nearest to 25, right? That means हमें 10 को बढ़ाना पड़ेगा. And what is the direction of the child where it has the greater node than the root node? In the right direction, obviously. So we need to move it in the right direction. So when we move it in the right direction, at the first iteration, my answer is now pointing to null. So we move it in the right direction. And now my current node is, or let's say root node is 15. And again I am comparing with 25. Again 25 greater than my current node. 15 को मैं बढ़ा के 25 के पास पहुंचना है. That means 15 को बड़ा करना है, right? And where we can find the greater node? In the left or in the right hand side? In the right hand side, obviously, right? Again the answer it remain nulls because 15 is already less than 25, right? If we would have exceeded 25, then only it will make sense to store our answer, right? To keep a track of our answer. Okay, so we will again move right, and we move right and we come to the current node as 30. Now 30 is greater than my given key. So definitely I will store this particular 30 in my answer because it is satisfying the condition of greater than or equals to x, right? But अभी ये जो 30 है, हो सकता है कि हमारे पास कोई एक ऐसा वैल्यू हो जो 30 से लेस हो और 25 से ज्यादा हो, राइट? इफ दैट इज द केस देन डेफिनेटली हमारे पास और भी नियरेस्ट वैल्यू प्रेजेंट है. तो अगर 30 को 25 के और नियर पहुंचाना है, सो दैट मीन्स 30 को रिड्यूस करना होगा. एंड इन विच डायरेक्शन आवर चाइल्ड इज प्रेजेंट in the lesser number? In the left hand side. So definitely we will make a call to the left side, and I will come at now at this level. I will come at this node of 27. Now 27 again greater than 25, and 27 is also satisfying the condition of greater than equals to x. So definitely we will update our answer as 27, and then we'll again make a left call because ऐसा भी हो सकता है कि 27 is still greater than 25. So we can get a number which is less than 27 and greater than 25 as well. जैसे यहाँ पर अगर 26 होता also तो हमारा 26 आंसर होता, but in this case we don't have that 26, right? So what will happen? It will move again left and it will hit the null. So when it hit the nulls, that means you have iterated all the levels in your BST and you need to stop, right? So please try to code this similar approach in your code editor and then we'll resume again. So I hope you were able to do it. So let us write a particular pseudo code, right? So we will have a, let's say, while loop which will run for while root not equals to null, right? And when we were moving the calls, when we were taking the calls, so when I'm saying that my root dot data is less than key, this one, right? Then I'm moving in the right direction, so I will say move right. And in the another case, if my root dot data is greater than key, then I'm storing the answer. I'm storing my root dot data as answer and then making a call for left. What is that third case? Let's say in your binary search tree, your root dot data is get completely equals to k, right? Then what you will just say? You will just say that return root dot data and you have reached your answer, right? Okay, let us proceed ahead to the code now. So that's the code here. As you can see, the same test cases. If it is equals to the given key, return root dot data. And what else we discuss? If the root dot data is less than key, definitely root dot data अगर less than key है तो उसे key के पास पहुंचाना है और वो खुद अभी छोटा है तो हमें उस डायरेक्शन में जाना पड़ेगा जहाँ पे root dot data की possibility हो greater होने की. And in which among the child left and right has the possibility to be greater? The right child. So we make it a call to the right child. Similarly, for root data greater than key, then we store the result and move it to the left. And we have a while loop while root not equals to null. We saw in the while doing the iterations, we saw that when it hit the null, you need to stop your iteration, because this hitting the null, it means that you have iterated all the levels of your BST. So इस पॉइंट को नोट करते हुए हमारी टाइम कॉम्प्लेक्सिटी क्या हो जाएगी, सिंस वी आर इटरेटिंग ईच एंड एवरी लेवल एंड जस्ट वन नोड, राइट, बिकॉज ऑफ दिस यूनिक प्रॉपर्टी वी लेवरेज दिस कंडीशन, और हम डिसाइड कर सकते थे कि हम किस डायरेक्शन में मूव करें, लेफ्ट और राइट, विदाउट विजिटिंग ऑल द 2 नोड्स इन वन पर्टिकुलर लेवल, राइट. सो डेफिनेटली हमारी टाइम कॉम्प्लेक्सिटी क्या हो जाएगी, ओ ऑफ हाइट ऑफ द ट्री, एंड स्पेस कॉम्प्लेक्सिटी क्या हो जाएगी, ओ ऑफ 1. सिंस दिस इज नॉट अ रिकर्सिव अप्रोच, इट्स एन इटरेशन अप्रोच एंड वी आर यूजिंग जस्ट सम पॉइंटर्स, इट वुड बी ओ ऑफ 1. Oh, great. Let us compile and run. Then we will hit the submit button for this particular code. I will attach the problem link as well as the solution link for my DSA repository in the description. You can take help from that. Let us wait for the compilation. So compilation has been run successfully. Let us hit the submit button and we will end this video. So great. All the test cases has been passed successfully. Let us end this video and let us meet again in the next question of our binary trees playlist. Till then, keep learning, keep growing. Bye-bye and take care.